Yeah, so going to solve power of 3 lead code easy problem. So this is a very easy problem. So okay, given an integer n true, given an integer return true. Okay, if it is a power of 3, otherwise return. Okay, fine. An integer 3 if 3 exists, integer x such as okay. So n equal to 27. This is a uh, power of 3 that is equal to, so that this is this is also not power of 3. So that's why we have returned false. Only this condition is true, power of 3. So that's why. Okay. So what we have to do, so I'm going to solve this question using of like what's called like simple approach, like simple mathematical approach I'll use. Like what I'll do. So like okay, fine. I'm going to write the solution. Like if like I'll check like because here like power of 3 must be positive, right? So those condition I'm going to write. If n is less than equal to 0, so that time will return false. And in other condition, like I'll try to like I'll try to keep dividing by like dividing n by 3 as long as it is a divisible for this condition. Okay, so while n modulo 3 equal to 0, what I'll do n equal to n divided by 3. That's it. Here I'll return n equal to 1. If n becomes 1, it was a power of 3. So let's see. Yeah, done. So for this time complexity will be O of log n3 because we have divided by 3, right? So that's why time complexity will be O of log 3n, and space complexity will be O of 1 because we haven't taken any extra space. So like here what I have done, I used here like normal iterative division approach. Like here if a number is power of 3, I dividing it repeatedly by 3, and like will finally reduce it to 1, and I handle edge case where n is n is less than equal to 0, so that time we are returning false. So like that we have done. And in other scenario what I have done, then I used a loop, and in that like I divided until so long it is a divisible by 3. So okay, fine. Now I'm going to solve power of 4. And to use same approach, same condition. Given an integer n, we have to return true if it is a power of 4. If it is not, then we'll return false. So this is this n is power of 4, so that's why we have written true. This n is not a power of 4, so that's why we have written false. And 1 is power of 4, so 1 becomes it one it becomes 1. So that's why like if we'll divide, if we'll give power of 4, so that time it will be become 1 only. So that's why we have written here true. So if n is less than equal to 0, will return false value. Otherwise we'll check same thing what we have done in power of 3. We'll give one while loop n modulo 4 equal to 0. Then same thing we'll do, n divided by 4. That's it. It will return the same value. Then I'll check for last condition, return n equal to 1. Yeah, so here what I have done here, like okay, so here like time complexity will be O of log 4n, because like here division will reduce number by factor of 4, so that's why uh, time complexity will be O of log 4n. And here we haven't taken any extra like memory, so that's why space complexity will be of 1. So yeah, that's it. Like here, like we use like same thing what we have used on power of 3, like iterative division algorithm. So yeah, that's it for today. Thank you.